Hi and welcome to this TY Higher Level Maths Coordinate Geometry of the Line Revision Module video. This video is here to help you to revise the coordinate geometry of the line topic from Junior Cert Higher Level and to help you as you move into the Leaving Cert Higher Level Maths course. So if you've not already done so, I would advise you to go and watch the video which covers working with the formula in our log tables. That is also available on YouTube and is linked in the description below. This video is going to work beyond those formulas. So we're going to look specifically at checking if a point is on a line, calculating the X and Y intercept, the slope from the equation of a line, working with parallel lines, and working with perpendicular lines. It is important that before you work with these that you're familiar with all the formulas that you need to be and you are familiar where they are and how they work. So this is page 18 of your log tables. We're going to focus on the first four formula and also this little picture here at the top. So this little picture here this is a very important little piece of information that they gave you, and the specific pieces of information that are very useful are these ones here, which is 0C, and how to label our points, x1, y1 and x2, y2. You might think that that's quite a straightforward little piece, but actually the number of students who label their points incorrectly is very big. So it's really important that you keep an eye on that. 0C is linked to this second formula for the equation of a line. So y equals mx plus c. It's that constant there at the end. So when you're working through this video, it's a good piece to have open, that page 18 in front of you, so it can help you as we work through the questions. So let's take example 1, checking if a point is on a line. So this is the same formula to check if a point is on a line or on a function, or as we move into the Leaving Cert course, if it's on a circle. So what we're going to do is we're going to use substitution. So we're labeling our point, that is the x part, that is the y part. The equation of the line is 5x plus 3y plus 6 equals 0. And this is 5 times, instead of x I'm putting in 3, plus 3 times minus 5 plus 6 equals 0. What we're trying to do is to see, does this work? Because if that point is on the line, this equation should be valid, i.e. the left-hand side should equal the right-hand side. If it does not, then that point is not on the line. So let's see what happens. We get 15 minus 15 plus 6 equals 0. So we get 6 equals 0. So because that's not valid, we are hopefully all okay with the fact that 6 does not equal 0. We will therefore, the point 3 minus 5 is not on the line. Okay, so this is a great way to check. Notice here that they asked, is the point on the line? Sometimes these questions come in the form of verify that this point is on the line. So you already know what the answer should be. You already know that it should be yes, and if your answer is not yes, you'll know something went wrong. However, here we have to trust in our answer. Where they say justify your answer, this substitution part that we've done is absolutely fine. So now let's talk about where a line crosses the x-axis and the y. The x-intercept is where the line crosses the x-axis, and to calculate this, we sub y equals 0 into the equation of the line. Sometimes students find this a bit counterintuitive. We're working with the x-intercept, we're working with the x-axis. Why are we letting y equal 0? But if you think about these points, so let's take this point here as minus 1 and this is minus 2 on the x-axis. The x-intercept here is going to be minus 2, 0. Any point that I pick along the x-axis is going to have a y value of 0. So that is where this y equals 0 is coming from. Similarly, when we talk about the y-intercept, it's where the line crosses the y-axis. And to get this, we sub x equals 0 into the equation. So let's take 1 and 2 here. So the y-intercept in this case is 0, 2. No matter what point I take on the y-axis, the y value is going to be, well, it could be 0, but it's going to take some number, and the x value will always be 0. And that is where the x equals 0 is coming from. So let's try an example. Given the equation 5 plus y minus 2x equals 0, find the coordinates where the find the coordinates of the points where L cuts the axis. So they are the x-axis and the y-axis. So x-axis, we let y equal 0. So what we do is we do 5 plus 0 minus 2x equals 0. Subtract a 5 from both sides. Minus 2x is minus 5. So x is equal to minus 5 over 2. Minus 2, which simplifies down to 2.5. So we get 2.50. Again, I think coordinate geometry is one place where, although I highly encourage top-heavy fractions as much as possible, it can be very hard to understand what 5 over 2 is. So writing it as a mixed fraction or as a decimal will be preferable in this case, so you can really see what that means. So now we're going to do the y-axis. So to find the y-intercept, or where across the y-axis, we let x equal 0. So that is 5 plus y minus 2 times 0 equals 0. So we get 5 plus y equals 0. Subtract a 5 from both sides and we get y equals minus 5. So we get 0 here and we get y equals minus 5. So not very difficult questions, but you are required to understand the two main pieces that we need to do that. So to find where it crosses the x-axis, we let y equal 0. To find where it crosses the y-axis, we let x equal 0. So now let's take a look at working with the equation of the line. In the previous video, we focused on working with the first formula. What I said was in the last video was, in general, the first formula is when we want to create the equation of the line. The second formula here, which I've just highlighted, is when we're given the equation of the line. That is a really general rule of thumb. It won't be 100%, but it'll give us a really good guideline of what we can work with most of the time. So we're working now to see if we can get slope from the equation of a line. So the table below gives 6 different equations. Which line has the greatest slope? And give a reason for your answer. So I'm going to work with y equals mx plus c. And basically, when I'm given an equation in the form of y equals mx plus c, there's 2 things I can pick out very quickly. The first is the slope, m. It is the coefficient of x. So here I have 3, 5, we'll talk about this one in a second, minus 2 and 4. So this one here, remember, if I have an x, I can always write it as a 1x. So in this case, my slopes can be m equals 3 in this case, m equals 3, m equals 5, m equals 1, m equals minus 2, and m equals 4. So from this, which line has the greatest slope? So the one with the greatest slope is the biggest number, regardless of whether it is positive or negative. And in this case, that's a 5. So our answer is line 3 has the biggest slope. Now, I want to do something else here that, although it's not asked in the question, it would be good to do while we have this. And that is working with this C. So what the C does is it tells us what the y-intercept will be. So it'll tell us where this line crosses the y-axis. So we have a minus 6, plus 12, plus 20, minus 7, plus 4, minus 16. So straight away for all of these, so I'll make a heading, that's my slope. We're now going to talk about the y-intercept. Okay, so my point here, y-intercept, so the x is 0, minus 6. And this is linking back to that little diagram on the top of page 18 in your log tables, which shows us the point 0C. And we get 0, minus 7, 0, 4, and 0, minus 16. It's important that you're able to pull out both of those pieces of information, so your slope and your y-intercept, given the equation of the line, because it can be very helpful. And we'll do some examples so where you can see this in more detail. So now we have the same question again, find the slope from the equation of a line, although what I'd like you to notice in this case is the equation of the line L is given as x minus 3y minus 6 equals 0. So just like before, we're using y equals mx plus c, but you'll probably notice that our formula or our equation of the line, they are not looking like each other. So that's what I want it to look like. And it is currently x minus 3y minus 6 equals 0. So in order to work through this, I need to rearrange that so it looks like y equals then the x, then the constant. So what I'm going to do is I'm going to subtract an x from both sides. I'm then going to add a 6 to both sides. Just because I'm not a huge fan of the negatives, I'm going to multiply across by minus 1. So I get 3y equals x minus 6. So does that look like y equals mx plus c? You might go, yeah, but actually it doesn't, not quite. And the reason is the y is on its own. It should be y, i.e. with a coefficient of 1. Here we have a 3y. So just to give myself a bit more space, I'm going to write it down up here. So in order to make that look like just a y, I'm going to divide everything by 3. So these cancel, I'm left with y equals x over 3 minus 2. Now, it's still not quite in the form y equals mx plus c, so I'm going to work a little bit up here. So if I have x over 3, that's another way of saying 1/3 of x. Because if we were to multiply 1/3 of x, I could write that as x over 1 and multiply across the top to get x and across the bottom to get 3. So it's really important that you're able to separate out any numbers, be them fractions or otherwise, from the x, because being able to rewrite x over 3 as 1/3 of x. Another way you could think of that is that's x divided by 3, so multiplying by 1/3 or getting 1/3 of something is the same as dividing by 3, but you need to be able to do that, otherwise you're going to find it very hard to get the slope from any line. So now it's in the form y equals mx plus c. I can work out my slope, which is 1/3, and my y-intercept, which is 0 minus 2, but I only need the slope, so excuse me. So the slope of line L equals 1/3. So it's a nice little piece to be able to do, but it does take you a little bit of manipulation in some cases. So now let's have a little chat about parallel lines. Parallel lines are lines that never meet. So in our example here, M and N will both keep going forever in both directions and will never ever meet. So parallel lines, in order to do that, must have the same slope. So remember from our last video, we talked about slope as being a measure of how slanty lines are. So if one was more slanty than the other, or one was less slanty than the other, they would eventually meet. They have to have the same slopes in order for them never to meet. So now let's use the equation of the line similar like we had done before, but now we're given a diagram and we need to do a little bit of matching. So just like before, I'm going to work through this and I'm going to say y equals mx plus c. All of them are y's, so that's good. So the coefficient of the x tells me the slope, and the second piece of information is that y-intercept. So I'm going to make a little note here. So m equals 1 and my y-intercept is 0, 3. So that's the point it goes through. Here the slope is 1 and the point it goes through is 0, minus 3. Here equals 2 and the line it cuts is 0, 3. So let's look at the question and see is there any more information given. The coordinate diagram below shows the lines Q or S and T, and it tells us Q is parallel to S. So let's just see this. So Q, this line here, is parallel to S. And here we have OR is parallel to T. So as we know, parallel lines mean they have the same slopes. So parallel lines, same slopes. So we know that we're trying to match everything except S. So we can ignore S for a second because S is given here. So looking at this, I have M equals 1 and M equals 1. So they must be parallel. So those first two must be OR and T in some kind of order, because S is parallel to Q and there's nothing there. So like straight away I can say, well look, this realistically is going to have to be Q, because S is parallel to Q. Well, this equation here is M equals 2. S must have some other slope, and I can actually work out that that is M equals 2 as well. So let's take a look then at the first two, which must be OR and T, and let's see if I could figure out which one is which. Well, let's take a look at the y-intercept. I have one here that has a positive y-intercept. So if I look at OR is crossing the y-axis in the positive part. T crosses it in the negative part. Based on that, since this is positive and this one's negative, I can say that this is OR and this one here is T. So similarly, Q crosses it at a positive point and the same point as OR. So does that make sense? Is 0, 3 the same as what we saw up here? And yes, it is. So therefore, this point down here where S crosses the y-axis must be the same as where T crosses it. So that must be 0, minus 3. So now I have the two pieces of information, and I can recreate using y equals m, which is 2x, plus c, which is minus 3. I can create its equation. So this is a hugely important example. Without having the understanding of y equals mx plus c, this question will be very, very difficult to work with. Keep an eye on the things we know. Although the axes themselves were not broken into actual numbers, we should be able to identify where those values are positive and where they are negative. So let's take another example and look specifically at parallel slopes. So the line A has a slope of 4 and they want us to find the slope of B if, and they've given us this little thing here, A, and what that middle line there means is parallel. Notice that they look like two little parallel lines. So A is parallel to B. So therefore, slope of B is also equal to 4. Since parallel lines have the same slope. And that's so important. Remember, slope is a measure of how slanty a line is, so parallel lines, because they'll never meet, their slopes will be identical. They will be the same. So let's look at an extension of this even further to work with the idea that the two lines are parallel, but in the form of working with some of our formula as well. So the equation of line L is x minus 3y minus 6 equals 0. Find the slope of L. So we're going to work with this equation here, y equals mx plus c, but we're noting that currently it's not in the correct form. So x minus 3y minus 6 equals 0, so we need to rearrange this. So we get minus 3y minus 6 equals minus x, and then we're going to add a 6 to both sides, minus x plus 6. I'm going to multiply across by minus 1 to change our signs, and we get 3y equals x minus 6. So we have 3y equals x minus 6, but I want it as y equals mx plus c. So we're going to divide everything by 3, and we get y equals a third of x, that's another way we can write it, minus 2. And the reason that we write it like that is so we can really easily see the slope, which is the coefficient of x. So therefore my slope m is equal to a third. Remember, m is our universal letter for slope as we work through the coordinate geometry of the line. Now, the line K passes through the point 1 minus 2 and is parallel. So they've told us that K is parallel to L. So we know that if the slope of L is a third, therefore the slope of K must also be a third, because parallel lines have the same slope. So I have my slope here. I can label this x1, y1. And now I'm coming along and I'm going to work with this first equation. Remember, we said the first equation is for when we want to find or build the equation. Y minus y1 is equal to m bracket x minus x1. Y minus 2 is equal to a third bracket x minus 1. Now, don't like that fraction, so I'm going to multiply both sides of my equation by 3 to get rid of that. And we're left with 3 times y plus 2 is equal to 1 times x minus 1. So multiplying that out, we get 3y plus 6 is equal to x minus 1. And rearranging this, I'm going to bring everything over to the right hand side. So I'm going to subtract a 3y, and I'm going to subtract a 6, and we get x minus 3y minus 7 equals 0. And you might notice something very interesting at this point. When lines are parallel, this part here remains the same. Okay, so the constant piece will change, but the x and the y and their coefficients will stay the same. You're going to be using that a little bit more as you move into Leaving Cert higher level, but it is just good at this point to recognize that that happens. So now let's talk about perpendicular lines. So you will already know from geometry that perpendicular lines are lines that meet at a right angle or a 90-degree angle, and you can see that over here in the diagram. The right angle is marked with a little red square. So perpendicular slopes have what we call opposite reciprocal slopes. So you should have already heard the word reciprocal, and now we're talking about opposite reciprocal. So what does that mean? Well, in simple terms, you take the slope, you flip it or you turn it upside down, and you change the sign. So where you might have already seen reciprocals, and where you've definitely seen them but maybe didn't use the term reciprocal, is when we are dividing by fractions. Instead, we multiply by what's called the reciprocal of that fraction, or you flip the fraction and multiply. So reciprocal is just a more mathematical term. So another way to think about slopes of perpendicular lines is that when they are multiplied together, they give us minus 1. So this part could be very useful when we have to prove that two slopes are perpendicular. I would definitely be using the idea of opposite reciprocals if I ever have to get a perpendicular slope. But if I've got two slopes and I'm asked, are they perpendicular? A great way to really demonstrate that is to show that when I multiply them together, I get minus 1. So what opposite means is that we're going to have to change the sign. And if you look at our two lines here, It is impossible to draw two lines that are perpendicular without one being positive and one being negative, except of course for the x and y axis themselves. So any other lines that we draw, so that are not horizontal and vertical, we're going to find that one is positive, so in this case here's my positive line, and one is negative, there's my negative line, and that's where the opposite comes into it. So let's take some very basic examples. The line K has a slope of 4 over 5. Find the slope of L if L is, and we have this funny symbol here, and this symbol here means perpendicular. And notice that it actually looks like a little perpendicular, or set of perpendicular lines. So if L is perpendicular to K, so we have the slope of K is equal to 4 over 5. So I'm going to use the opposite reciprocal. So the slope of L is then going to be 5 over 4. So I flip it and I change my sign. So it's minus 5 over 4. The slope, line L has a slope of minus 5. Find the slope of T if S is perpendicular to T. So the slope of S is equal to minus 5. Now remember that every whole number can be written over 1. Therefore, the slope of T is, when I flip it, 1 over 5. And that should be a minus, but I'm going to change the sign. So I get 1/5. And that is the slope of T. So it's as simple as that. It's not difficult, but it is something you do need to remember. So for our last example, let's put everything we've learned so far into practice. Find the slope of line L. So when they've given me the equation and I want to find the slope, I'm working with y equals mx plus c. So I have 5 plus y minus 2x equals 0. It's not in the form of y equals mx plus c, but I can rearrange it. I get y is equal to adding 2x to both sides and subtracting a 5 from both sides. I get y is equal to 2x minus 5. Therefore, the slope of L is equal to 2. Remember, y equals mx plus c. Y equals mx plus c. I'm looking specifically for the slope, so the m, and that is the coefficient of the x. So now the line J goes through the point 11, 6 and is perpendicular. So we have J, which is perpendicular to L. So therefore the slope of J is going to be the opposite reciprocal. So the slope of L is 2, and that can be written as 2 over 1. So we flip it and we change the sign, so minus a half. Now we find the equation. So I have my slope, which is minus a half. I have my point, which is 11, 6. Remember labeling the point x1, y1. I then go and use my formula for building the equation, which is this top one here. And we get y minus y1 is equal to m bracket x minus x1. Y minus 6 is equal to minus a half times x minus 11. We first of all get rid of that fraction by multiplying both sides by 2. And we get 2 times y minus 6 is equal to minus 1, what's your sign? X minus 11. Multiplying that out, we get 2y minus 12 equals minus x plus 11. I'm going to bring everything to the left hand side, so I'm going to add an x to both sides. So x plus 2y minus 12, and I'm going to subtract an 11 from both sides. So I have equals 0. We get x plus 2y minus 23 equals 0. And that's our equation for J.